parabola, but today we're going to look. I'm going to sketch all these graphs and see the difference between them when you have a number in front of x squared. Starting with -2, you get 4, 1, 0, 1, 4. Does that make sense? You square it and then plot the points. Go. So you go 0, 1, 4. Yes? Excellent. Good. Correct. Huh? What do you mean? You have to put a bracket. So, for example, if you're going to square -2, make sure you put a bracket around -2 before you square. Because you have to square the negative. If you don't put a bracket, it ends up squaring the 2 without squaring the negative. You will get a negative answer. Yeah. All right, can you join the dots, please? Okay, does it make sense? We drew y equal to x squared. Alright, how about the next one? In my new sitting plan, perhaps. Alright, now continue. We'll get back to you. Alright, let's do the first. Yeah, we may try that. Say again? Yeah, page 8. No, quick. Alright, let's continue. So what we do is, if you have 2x squared, what you do is, you do on a calculator, put 2 bracket times bracket -2 close bracket squared. Does that make sense? You get 8. Can you see it doubles the values? Let's use a green pen. So 2x squared means you double the y value after you square. So the next one you get 2, 0, 2, 8. Does that make sense? Continue on. So we're going to plot the points. 0 here, 2, and 8. Yes? Say again? Yeah. Oh no. Yeah, you should. So you know the difference between them. So see this one, yeah? Yep. Hang on. Let me just join the dots. So this is y equal to 2x squared. Can you see it gets more narrow as a result of having a 2 in front? And then let's look at what happens when you have a half. It ends up having the 4, which is 2, 0.5, 0, 0.5, 2, right? You halve it. Does that make sense? Because of the half x squared, you halve the squares. Does that make sense? All right, now, so what we do is let's plot the points. That's half, that's half, that's half. Yep. And then you're going to join the dots.
That was wider.
Wider. So see the half having a smaller number in front, it makes it wider. Does that make sense? Because you have a lower y values. So the lower y values makes the graph going wider. Does that make sense? Whereas a higher y value makes the graph more narrow, more steeper. Yes? Useful later on when we solve problems where the formula for a problem is a quadratic, which when you draw it becomes a parabola. Yes?
I don't understand why the line is going all the way up.
Oh yeah, but of course the graph goes on forever, but it's just that my table of values somehow stops there, right?
Yeah, but it's like why does it?
Oh, you could. So if I go all the way up, you just go outside the graph because you keep going, right? Yeah, you could. So if I'm going to go all the way up, you just go like this, right? You just go outside the graph. Yeah, so it doesn't just stop there. That's why there's an arrow. Yeah. So the arrow indicates that it will keep going in that direction. Good question, though. All right. So again, what's the equation? Now, I've labeled each graph. So the half x squared is the wider one. 2x squared is more narrow. X squared is the blue one. Yep. All good. Thank you. All right. Can we, let's go through CDE. We're going to answer some question about the graph that we already know. Write down the equation of axis of symmetry and corners of the turning point. So for all of these, the vertex is over here, right? That's your vertex. So the vertex is, or the turning point, yeah, the vertex is at the origin. Turning point, this is the minimum turning point at 0, 0. Yes? Another word is the vertex. And the axis of symmetry is the line, or is the y-axis. That's the axis of symmetry. So x equal to 0. So the axis of symmetry is x equal to 0. Yes? So again, would the axis symmetry ever be different? Yeah. So of course, when later on, next exercise, you will investigate parabola when shifted to the right, where the axis symmetry is no longer the y-axis. Yep. Because any vertical line is x equal to number. Revise chapter 4 when we did the equation of the line. So for example, this is 2, so you get x equal to 2. So if it's 0, x equal to 0. Does that make sense? Because all the x values are 2. All the x values here are 0. Thank you. Now let's compare the two graphs. Which one's the wider one? Which one's more wider or narrow?
Y equals half.
No, look at this one. They're asking you to compare these two. So you say y equal to 2x squared is narrower than y equal to x squared. Continue on. Now, how about we compare the graph of half x squared and x squared? Is it wider or narrow? So y equal to half x squared is wider than y equal to x squared. Any question? All good? Wider, narrower, or wider? Yeah, more. Yeah, you're actually right. More narrow. Yeah, you're right. Not more narrower. More narrow. Yep, vertex. Yeah, another word for vertex is turning point. Is more narrow. Thanks for the correction. Okay, let's move on to the next page. You all ready? All ready? One. Yes, one more page. Because we have to look at the concave down parabolas. It's the same question. It's all concave down. Have a try. So you go negative x squared, you get negative 4. Exact same thing, except you got negative instead of positive. Do you want to have a try? Concave down. Yeah. So you're going to times it by 3, you get triple it, so you get negative 12, negative 3, 0, negative 3, negative 12. Yes? And the negative half, you halve it.
When
Maximum turning point, yep.
when x is 0,
Yep.
y also is always 0.
Yeah, because you put 0 there, it doesn't matter if there's a negative, it still becomes 0. So negative 3 times 0 squared is negative 3 times 0, which is 0. Yep. All right, so, yeah, actually I shouldn't use green, I should use purple. But the good thing about computers allows you to change things. I'll show you, it's very cool. So that's the purple. There you go. All right. Yeah, I know. I love computers. It makes things more flexible. Okay, can we try to draw them now? Let's draw them. Let's draw the first one. We've got concave down parabola. 0. I forgot to label x and y axis. 0, 1, and negative 4. Yep. And join the dots. Okay, arrows, that's y equal to negative x squared. And let's try the green one, the more narrow version. Negative 3 and then negative 12. It's going to be very narrow.
Wait, what?
Because you got negative 3, right? It makes the y value more lower than it should be. So therefore, you're going to get more narrow. Watch this. I'm going to use this pen to draw. Okay, that's y equal to negative 3x squared. And then we got this one, negative 2, negative half. Oops, didn't work out. Oops. Okay, this is y equal to negative half x squared. Does that make sense? So the same idea goes, the bigger the number, more negative it is, the more narrow it becomes. The smaller it is, the more wider it becomes. Just that the negative just makes the graph goes upside down. And we call this concave down parabolas. So you may just fill in this detail. It's very easy to say. The turning point is 0, 0, and the axis symmetry is x equal to 0. Okay, they have the same axis symmetry and the turning point, and this one will be more narrower, or actually we'll say more narrow, and the other one will be wider. Okay, I'll leave the rest to you. Please start the exercise today. What exercise is that?
Exercise 10F.
10F. Okay, can you please do exercise 10F? Okay, start now. There's plenty of time to do at least a couple of questions before you start your weekend. Thank you.